So good afternoon all the attendees, and today we are here for the workshop on biological risk management. Pathogenic microorganisms pose a significant threat to community and also pose a severe threat to people who handle them in the laboratory. Workshop on biorisk management, which introduces the participants about the basic concepts of biohazards and essential elements of biosafety. The outcome of this would be the participants will have the chance to advance their biosafety knowledge in the areas such as risk identification and risk mitigation. The source person for today would be Dr. Neetaraj Sharma and Dr. Gaurav Kumar along with Dr. Minhaj. And now over to Dr. Minhaj for the content of the day.
A very good afternoon to all of the attendees and all the panelists present over here. I think it's a very rainy day, and even in the challenging day, we all are here to attend the workshop or the learning of the life, that how to protect ourselves from the biorisks. So we are all well aware about the biorisks, and in the next 1 hour, you will be getting to find out some more interesting facts and yes, very important, how to prevent the life from all those bio threats. But before that, it is my responsibility that I would be introducing the panelist of today, which is leading by Dr. Neetaraj Sharma, who is currently the Dean of School of Bioengineering and Biosciences, and Madam is also Professor and Head of the school. It is my pleasure to introduce Dr. Neetaraj Sharma, who has completed her PhD from Jivaji University, Gwalior, having more than 25 years of experience that comprises of teaching as well as research. Under ma'am's supervision, the students have explored the world of waste management, and that has been resulted in the form of 75 papers and not only that, it also resulted in 40 number of patents which has been granted so far. As far as her work is being concerned, the research work has been immensely awarded in the terms of projects that has been run under her supervision. More than 10 projects, approximately we can say 11 projects has been run under her supervision, that has been in collaboration with the international reputed brands. And in these, not only this, the cream of the cake is that she has been a visiting faculty of British Columbia University also. And not only that, apart from that, she has been working in collaboration with McGill and Lowell University as well. Dr. Sharma is also providing the opportunity to the fresher young scientists to work in collaboration with international scientists, and that can be easily seen in her collaborations. I'm expecting that this is just the beginning of the journey, as many such more part is written in near future, and that is possible when the young aspirants like who are present today, they will get to know what our school had in us, so that we could produce the future biotechnologists. You are most welcome, ma'am, onto this platform where our aspirants are going to be guided under your excellent supervisions in near future too. Along with that, I'm welcoming Dr. Gaurav, who is a co-panelist with ma'am. Dr. Gaurav is currently working as Associate Professor in Department of Microbiology, School of Bioengineering and Biosciences at LPU, He has been a doctorate from VIT, Tamil Nadu. And his main research interest is focusing upon medical microbiology, herbal medicines, marine natural products, and nanotechnology. He also served as an editorial member and reviewer for many prestigious journals. And not only that, he has been an author of more than 80 articles and has contributed chapters for reputed publishing houses. And I'm pretty sure that the experience that Dr. Gaurav is having in delivering the understanding of biosafety measures will be an outcome of today's webinar. So it is my request to all of the aspirants to stay active during the whole session, and you will be definitely having a whole lot of queries at the end of the session, which we will be loving to answer. So I think I would not take much of the time as I have already taken. So over to you, Neeta ma'am, for a brief introduction about the workshop that we are going to conduct today. Over to you, ma'am. Ma'am, kindly see if you are muted. I'm not sure.
Risks. So when we see the current scenario, it has become the need of an hour to educate our youth about the protection from bio risks agent or the causative agents which are causing the various kind of risks. We have very good examples of coronavirus, and in current time you might be incurring coming across to monkey pox news also. So such type of emerging microorganisms nowadays are very frequently observed. So it is at most important to enable our youth about the understanding of how we can protect ourselves from the such kind of biorisks or the biohazards associated with the microbes. So in this concern, we have with us the expert of biosafety, Dr. Gaurav Kumar. He has already taken lot many workshops to the students and the faculty members, and in this session he will talk about the various practices, procedures, equipments which are required for the management of biorisks, and you can say that biosafety in short. And I hope that the outcome of today's workshop will be fulfilled after the demonstrations, live demonstrations by Dr. Gaurav. So Dr. Gaurav, over to you. And we hope that the objectivity of today's workshop, that is the awareness about the biorisks and how we can protect ourselves from the biorisks will be satisfied and justified after this session and during the session. So thank you, Dr. Minaz and Dr. Gaurav. You can please start the demonstrations.
Thank you.
Rishi sir, please give rights to Dr. Gaurav.
That's okay. So, good afternoon, everyone. As you know, the intent for today's workshop, it is to guide you about basic concept of biorisk and biosafety. I was told that most of you are either school students or you have done your graduation in some course of life science like geology, botany, microbiology, biotechnology. So I will try to keep it very simple and I'll try to finish within 10 or 12 PowerPoint slides, and I'll also give you small demonstrations so that you can relate with the content in a better way. So I think all of you might came across to several news in recent times that doctors working in IMS hospital, while they were handling corona patients, they got positive for corona themselves. Similarly, you might have heard some nursing staff, some peons working in hospital or in diagnostic centers, they have also received some kind of disease while they are working with microorganisms. I hope all of you might have heard this kind of news in news channels. And that time, one thing might be coming to your mind that these people are doctors, they are nursing staff, they are technical experts, they have done all kind of education, they're working in very good institutes, and obviously they have all the protective gears. Still, why they're getting this kind of infections while handling the patients? Is it that risky? Whether working with microorganisms is that much risky? If it is so, then why somebody will get into this? If that is the kind of condition, then it becomes like a job of an army man where they can be shot any day. But in laboratories where you have everything which can protect you, still if you can get the disease, that means there is some mistake. That means we are making some mistake while handling the microorganism. That means our basics are not correct. Therefore, it is very, very important to learn about the risk, what is the risk in the laboratories, and you should also learn how to overcome that risk. Let me give you one very simple example over here. For example, you are trying to cross a road, busy road. Will you cross the road without seeing here and there? Will you directly cross it without examining the risk? No, I don't think anybody does so. Any of us does not cross the road in that way. First, what we do, we look around us. We look left, right, we look in front, we look in back. Even if some vehicle is coming and we are feeling that the vehicle is at some distance, we assess it. We assess in our mind. Our mind works very fast. We assess the risk that, okay, by the speed I will cross, this truck or this bus may not reach near to me. So what we do, we always assess the risk in our life, whether we are crossing the road, whether we are cooking some food, whether you are making 2 minutes Maggie, whether you are making tea, or whatever work you're doing, we always do a risk assessment. And after risk assessment only, we will take our action to complete that work. So do we do that in lab also while handling the microorganism? That is very important. As most of you are aspiring to get into courses where you can study advanced biological courses like biotechnology, microbiology, genetic engineering, molecular biology, I'm pretty sure all of you are willing to get into this kind of courses, and there you might have to handle some material which are very risky, like microorganisms, toxins, okay, some kind of other hazardous materials, dangerous materials. So will it be? Can you handle them safely? That is very important. You should be in position to handle them safely. So in today's workshop, I will try to discuss how you can handle them safely if you are working into laboratories where you need to handle microorganisms or some other hazardous or dangerous materials. So I'll try to give you brief information about this in today's lecture in next 30 minutes. I hope all of you will be attentive in the session, and definitely if you have any queries, you can ask me in between or maybe towards the end of the session. So with this, I'm going to my first slide. So that is, what is biorisk? Biorisk can also be called as biohazard. What is biorisk or biohazard? See, in layman's language, I will explain you. Any risk, any danger which is created by biological material is called biorisk or biohazard. Now question comes, what is this biological materials? Biological materials could be anything which is coming from living things. But in biotechnology, in microbiology, usually we are considering that biorisk is arising from the microorganisms or parasites, right? Where the microorganisms like some bacteria, virus, protozoa, fungi, Okay, they can cause some human disease if they get into our body. If they get access of our body, they will enter in our body and they will cause some kind of hazard, some kind of problems in our body. Right? So the material, the biological causes the problem into our body is called as hazardous material, and the process is called as biohazard or biorisk. I hope it is clear to everyone. Now there was a committee. I will not name the committee head, although I have written in my slide. But the category, that committee has divided all the microorganisms into different risk groups. They have divided the microorganism in basically 4 risk groups based on their harmful potential, or you can say the disease causing potential. Some microorganisms are causing very severe disease like Ebola virus. I think all of you might have heard of Ebola virus. Some of you might have heard of Japanese encephalitis virus. I think some of you might have heard of tuberculosis, very common. Mycobacterium tuberculosis, which causes TB, tuberculosis disease. Some microbes are very dangerous, very deadly, while there are some microorganisms which does not cause any problems, like lactobacillus. I think most of you might be eating lactobacillus on regular basis. They does not cause any harm, they does not cause any disease. So microorganisms are having different levels of risk which they can pose to humans. Some causes low risk, some causes high risk. So that is one of the criteria for dividing the microorganisms into different risk groups. Then route of transmission, but how they are spreading from one person to other person. Why we are very much concerned about coronavirus? Because it is transmitting by inhalation process, by droplets. You are sneezing, you are suffering with corona, you are sneezing, and through your sneeze, somebody will get infection. But there are many diseases which spreads by direct contact. Until and unless you're touching somebody, you will not get disease. Some disease transmits by eating or drinking some microorganisms. Right? When you eat something which is having microbes, it will go to your body and cause a disease. So the microbes which transmits, the bacteria, the virus, fungi, which transmits by air, they are the most dangerous ones compared to the microorganism which transmits by any other way. And third thing, if this microorganism gets into the public, it from lab it goes outside. I think most of you might have seen in some Hollywood movies, if there is a virus in which these people are working, suddenly the virus goes outside and whole society is suffering with the disease. Right? So what is the consequences if this microorganism gets inside the public? The public, when public will get problem? If just think, if we have the treatment option for this, if we have medicine available for this, what we will do? Even if we will get disease, we will take the medicine and will get cured. Or maybe we are already vaccinated. If we have already taken vaccine, nothing will happen. But just think about the microorganism. For them, you do not have vaccine. Just think about the microorganism. For them, you do not have the drugs to treat. So such microorganisms could be more dangerous. Right? So keeping these 3 points in the mind, we can divide the microorganisms into 4 risk groups. Risk group 1, 2, 3, and 4. Risk group 1 organisms are very non-pathogenic, they are non-dangerous, while risk group 4 organisms are very severely hazardous, very dangerous, extremely dangerous. So this is the criteria for dividing. So obviously, when you are working in biotechnology, microbiology, you will have to handle the microorganism which falls into these categories. And if they are falling into these categories, they are causing different type of risk. And if they are causing different type of risk, definitely they can be dangerous to you. They can definitely be dangerous to you. And if they are dangerous to you, you should know how to handle them carefully, right? So say you some case studies, some cases I will tell you. I think then you will understand the things more clearly. See, for example, this is one case: laboratory acquired respiratory syndrome. This was a student who was working with virus. You know, one day what happened? He has to go for a movie. He has to go for a movie. And well, you know, as we know that our show time is starting. My show will start 6 p.m. You know, by 4 o'clock itself or 5 o'clock itself, our subconscious mind will start thinking about the movie. I have to go for movie. I have to go like this. I will have to change the clothes. Same thing happened with that student. and he forgot to wash his hands properly. He was working with virus, and later on he forgot to wash his hands properly. Later on, he went for movie and the virus went inside his body. He suffered with the disease, and not only he, many people around him also got the same disease. Later on, they all were quarantined. I think nowadays everybody knows what is the meaning of quarantine. So they were separated, they were isolated, they were treated. Some of them died, some of them survived. You can understand how a small thing can lead to severe problems, right? So these things shows that you must be following proper safety measures while working in the lab. Washing hand is also a part of biosafety, right? Similarly, see here, a rare infection killed plague researcher. Somebody was working on plague causing bacteria. The bacteria is Yersinia pestis, right? Again, they have not followed proper biosafety protocols. They were not, handling them properly, and see, they got the disease, and this person died. Very dangerous, right? Similarly, see one more example: West Nile virus. This is also a viral infection. I think all of you know about forest officers. We have a lot of jobs in agriculture sector and all, where people are becoming forest officers, agriculture officers, like that. So similarly, there was a forest officer in US, America, and UK. So there, one disease spreaded into the, some birds like crow and this kind of birds. A disease is spreaded because of this virus called West Nile virus. So the forest officers were having a instruction from the government that whenever you see any bird which is looking ill, just kill it, just shoot it. Okay, so that forest officer was also doing the same thing. In that process, what happened? He went very near to the bird, and then he shot that bird. Suddenly, what happened? From that bird, some splashes, some blood particles came and hit into his eyes. They went into his eyes, and what happened? That virus went to the virus went into the body of that person, forest officer. He became diseased, and later on he died. So this kind of thing shows that not only in lab, if you are working with any biologically dangerous material outside the lab, in field work, then also you have to be very precautious. Then also you should be taking all the safety measures. And I have a long list of such studies. I will not be discussing here just to, because of the lack of time. But I have lots and lots of such case studies where I can give you hundreds of examples like this. But I hope these 2-3 examples which I quoted to you, this might be making the things clear that when we are handling dangerous materials, whether it is a bacteria, virus, fungi, their toxins, or any other related material, if they are dangerous, we should be taking proper precautions, proper safety measures, so that we can handle them carefully. Now, how you will decide that what safety measures has to be taken, right? On what basis you will select the safety measures? So for that, you need to understand the basic concept of biosafety. So for that, first, obviously, you should know what is biosafety. So basically, biosafety is a combination of containment principles. So some principles means some theories, some theoretical aspects. You should know the theoretical aspects of biosafety. You should know the technology which is required for doing biosafety and the practices. See, you have the theoretical knowledge, you have the techniques available at you, but if you are not practicing them properly, you cannot achieve biosafety. So all these 3 things in combination is required to ensure biosafety: containment principles, the technologies, and the practices that are implemented to prevent, now I underline this, to prevent the unintentional exposure to pathogen. Pathogen is nothing but microorganism and toxin, and their accidental release. So these 2 words I have underlined over here because that is very important. Biosafety aspects can protect you only from unintentional release or accidental release. Unintentional exposure and accidental release. But just we will think of opposite words than these 2. Intentional release and intentional exposure. For example, you are working in a lab, you have a very dangerous bacteria. Obviously, you don't want to, expose yourself to it. You don't want to spread it in public. But just think, you are involved in some terrorist activities. You are involved in some bad activity. You want to steal it. You will steal it and you will spread it outside in the public. So that becomes intentional exposure or intentional release. Biosafety does not deal with such things. You know, if we want to stop the robbery, if we want to stop the stealing, if we want to stop any misuse, we should always use, but security measures. And similarly, here also, if we want to prevent intentional exposure or intentional release of microorganisms or any toxins or any hazardous materials, then we should be using the measures of biosecurity. I'm not going to discuss further about biosecurity today, but I thought it is important to tell you what is biosecurity over here, right? So, if you want to learn biosafety, you will have to learn three kind of things, or with the help of these three aspects, you will be able to develop various biosafety levels. One of them is standard microbiological practices. What is the meaning of standard microbiological practices? This is the basics of microbiology. This is the basics of handling the microorganisms. Okay, this is what you basically learn in any college or any institution, right? Where you will be guided how to grow a bacteria, how to grow a virus, how to dispose it of. Okay, while handling, what kind of precautions you should take. Okay, what are the safety guidelines? So all basics of microbiology, which you learn usually during your college time, is part of standard microbiological practices. Okay, let me tell you here, this is one of the most important concepts of biosafety. Without learning standard microbiological practices, you cannot do any work with dangerous microorganisms. We should strictly adhere to the basic concept of microbiology if we are working in any laboratory. We should be aware of potential hazard. Right? We should be aware that what procedure, what material which we are working in lab can be dangerous to us. We should be in that position where we are able to assess the risk. So, in biosafety, risk assessment is also very important. I gave you example initially that if you are crossing the road, what you do first? What is the first thing you do? You do the risk assessment. You assess the risk. You look around, you look left, you look right, and if you're finding that there's no bus, no truck, no vehicle is coming, and the time is sufficient in which you can cross the road, you cross the road. So what you're doing before crossing the road, you are assessing the risk. Similarly, in laboratories, you need to assess the risk, and it will be taught to you in your classes when you learn in college. These are the things which will taught to you, how to assess the risk, how to understand that this thing can be risky to me. And obviously, if you know this thing can be risky to you, you will always look for handling it safely. And for that, everything will be provided to you. I hope it is clear. And to ensure this, we should be properly trained and we should become experts of any of the technique which we are going to do in future. And in this, your college, universities, they will play a big role. Okay, where you can get proper guidance for all these things. Then comes the second element of biosafety, that is primary containment barriers. Now these are nothing, these are basically the equipments or the apparatus which is required to protect yourself while working in the lab. I'm saying protect yourself. Still, I'm not talking about the public, because being a biotechnologist, being a microbiologist, being a genetic engineering, scientist, you are the people who will be working with the material. So you are at higher risk of getting the infections or the problems. Therefore, it is very important that you should be using the equipments or the apparatus which can protect you from, hazardous materials. So as I told you, they minimize exposure to the hazardous material. They prevent contact. They control aerosols. Aerosol is nothing but the small droplets which can be inhaled by us. Examples are like personal protective equipments. I don't know how many of you know about personal protective equipments, but I'm pretty sure that all of you know about gloves, you know about the mask, you know about gown. You might have seen some pictures in the newspaper where some doctors, scientists, they're wearing some special type of gown, which you are seeing in this picture also in the bottom, right? You might have seen this kind of things, which is worn by some of the scientists or some of the doctors or laboratory staff who is wearing this kind of apparatus. So this is called PPEs, personal protective equipment. Okay, safety cabinets, biological safety cabinets. Okay, this is nothing but a box. This is a box where you can work, safely. You can also work in germs-free condition. We will be showing you, both PPEs, how the PPEs looks like and how the biosafety cabinets look like. We will show you both these things. I think then you will understand more clearly. Right? And then comes, if you're working with animals, you need cages in which ventilation system is there. Okay, so that kind of things can also be used. So all these things are part of primary containment barriers. What they do? What is the objective of theirs? Their main objective is to protect you from directly getting exposed to the microorganism, your own protection. And then comes the third element of it, that is the design and construction of the laboratory, which is also called a secondary barrier. We should be designing our laboratory in such a way that nobody is getting infection, or the microorganism is not going outside from your lab. It is protecting the environment and our neighborhood, okay, the people living around the laboratories or the hospitals. In this, some of the important elements are like designing of building, designing of the lab, how we are maintaining the ventilation in the lab, okay, use of some equipments like autoclave, cage washing facilities. There are a lot of things into it. Right? So these three things are three important elements of biosafety. With the combination of these three things of biosafety, that is standard microbiological practices, primary containment barriers, and secondary containment barriers, by using combination of these three techniques, we can develop 4 different type of laboratories, which is called as biosafety level 1, biosafety level 2, biosafety level 3, and 4. So if you remember, I told you earlier risk group 1, risk group 2, 3, 4. Similarly, I am now saying you biosafety level 1, 2, 3, 4. The bacteria, the virus, fungi which belongs to risk group 1 should be handled in biosafety level 1. The bacteria virus which belongs to risk group 4 should be handled in biosafety level 4. Biosafety level 1 laboratories are the basic laboratories, very simple laboratories, while biosafety level 4 laboratories are very, very advanced laboratories. They are the most advanced type of laboratories which we have. So I think this is the basics of biosafety. Obviously, I'm trying to concise all these things just within 20-25 minutes. But in each of these things, if you want to learn, you will have to learn a lot. Definitely, it will be useful to you only if you are getting into this field. But I try to give you basic idea. If you are interested in this field, definitely you will get a chance to work in this kind of levels in future. So now we will give you a small demonstration of PPEs, personal protective equipment, and in this, one of our PhD student, Mr. Inderjit Pal, he will be helping us, right? So we are going to focus it to you through the camera. I will tell you where. Right, so he will be going. So sir is focusing first, and after that we will be going. So can we make it full screen? I think it can be done. So he's Mr. Inderpal. He's our one of the PhD students. So whenever we are working using PPEs, we should be using them in a proper sequence. So first thing when we are using PPE is to clean our hands with sanitizer. I think nowadays everybody knows what is sanitizer. So he is going to first clean his hands with sanitizer. He's using 70% ethanol. You can also use isopropyl alcohol. It is up to you. I think all of you have used sanitizer a lot in recent times of corona. After after cleaning the hands with sanitizer, we have to wear the first PPE, that is gown. So gown comes like this, no packing. It's a sterilized piece of equipment. It will come like this in a packing. So now he will open this. It will open up as a gown. You should be busy. So you see opening this gown. So this is gown. This is use and throw. Let me tell you, this is use and throw. Only once you can use. You see, it is like a big overcoat kind of design. And see, he's wearing it. Let's say usually how usually we are wearing shirt, okay, where the open part is in the front. When they are wearing gown, it should be opposite. Okay, the closed part should be in front and the open part should be in back. Because see, if the open part is in front, anything can go inside from that. So see, he is wearing like this. I will be helping him a little bit in between. Right? See. So sir is helping him. You can see now he is down and you can see it's fully covering his shirt and everything. Now no microorganism through air and all can go inside to his clothes. So he will remain protected from any microorganism whichever we are handling in the lab. After this, the next step is using a mask. So he will be wearing a mask. We can use different type of mask. It is a standard 3-ply mask. Nowadays, I think all of you know you have used different type of mask in recent times. I think all of you might have heard of N95 mask. So that can also be used. Okay. But most of the time we are using this type of masks. But when you are handling dangerous microorganisms like tuberculosis, Mycobacterium tuberculosis, coronavirus, that time we also use N95 mask, which I think nowadays all of you have seen, right? So after wearing mask, as you are seeing him, he has been wearing this mask. Next step is goggles. We use goggles. Now you are seeing it is a big goggle. Okay. The goggles can be customized. The company who is making goggles, we can ask them to make a goggle which exactly fits to our face. Right. As you are seeing, he is wearing goggle now. And last thing we do is gloves. So you can see this is the glove box which you are seeing on the screen, and we are using gloves. So he is wearing the gloves. So wearing all these things, and working with dangerous microorganisms will protect you from getting infection or any hazard while you're working in the lab. See, now he's wearing the gloves. Right? So I hope everybody is clear how to do it, right? And how it looks like. Now he can work. Okay. So now you can see he is going to a biosafety cabinet. He is going to a biosafety cabinet, and you will see how to use the biosafety cabinet. See, what instrument you are seeing is a laminar airflow, and see, we can do anything in laminar airflow, right? Now see, anything you want to do, for example, you want to handle the pipette. See, this is, sir, this is the focus. See, he is using a device called pipette. So he is using a pipette. He can do anything, whatever he wants. So we do different type of experiments when we are working in lab. Obviously, right now within short span of time, we cannot demonstrate you the practicals because it takes a lot of time. But you can see. So like that he will be working. So this instrument what you are seeing in front of you is called laminar flow. Okay. Well, earlier if you remember, earlier I was saying you about biosafety cabinet. So we will show you now biosafety cabinet, how it looks like. Now Inder will be showing you biosafety cabinet. It is on, sir. See, this apparatus is called biosafety cabinet. So there is a lot of similarity between biosafety cabinet and laminar air flow. But this is more safer. It gives better protection. That's why whenever we are handling dangerous microorganisms, we use biosafety cabinet, not the laminar airflow. So we have many instruments like this. Several laminar airflow we are having in our department. I think around 15, 20 laminar airflow we are having. We have biosafety cabinets also. So when we work with such microorganisms, some microorganisms will work with it, right? So in this, this apparatus will give you more safe conditions to handle the microorganisms. Right? So this is how we work. Once we are done with our work, once we are finished with our work, now obviously we need to remove the masks which we have used. We have to remove the PPEs which we have worn. Now this is very important part. This is where most of the people make mistake. Right? Putting on is not a problem. If you put them on in a different sequence also, it does not matter. This is not a big problem. But when you are removing them, it becomes very important to follow a proper sequence. So now we will be showing you how to remove these PPEs in a proper sequence. So again, with the help of industry, we will be demonstrating you how to remove these PPEs. So you can do it. I'll tell you what should be the sequence. Step by step I will tell you. So as you have seen on the screen, the first thing we remove gloves. Gloves is the first thing which we should be removing while removing the PPEs. Just a second in there. Let it focus. We will be removing gloves. See how he is removing. So he is removing first glove, then second glove. See, he is not touching the glove from front. He is touching the glove from the back only, and then we will discard it in a dustbin. Right? After removing the gloves, it is very important to first clean our hands with sanitizer. So again, we will be using sanitizer. Right? See, he is using again alcohol-based sanitizer for cleaning his hands. See, and after that, because see, there is a possibility while you are removing gloves, somewhere you might have touched. Just to eliminate any chances of risk, we are cleaning our hands with alcohol. After removing this, you need to remove the goggles. Okay, so from back side we have to remove the goggles. We should not be touching the goggles from the front. Okay, like he has removed. And after removing the goggles, the next thing we should remove is the gown. Okay, so sometimes it becomes difficult for a person to remove the gown, so other person can help them, but it has to be opened from the back side because we have closed it from the back side. So similarly, we will be removing it from the back side. Right, so sir is helping him to remove this gown. As you are seeing here, don't touch something. Right, so we have to remove it from the. Okay, this is called removal of gown from inside to outside. Okay, and after removing gloves, I think gown. I think now the only thing which is left is mask. So definitely we will be removing the mask. So as you can see, from back side only we are removing this. So he's removing, and we will be disposing it off in the dustbin, right? So with this, so he's disposing it off, and finally you have to come and clean your hands once again at the end with the alcohol, and you are now ready to do your regular work. Right? That is how you use PPEs, you use biosafety cabinet, laminar airflow. That will keep you safe while working in the lab. Right? Other parts could be, laboratory design, which is part of secondary containment. So I think I've tried to give you some basic information related to biosafety. I hope all of you might be clear. With this, I think I will rest my lecture. If anybody is having any questions, queries, you can ask.
That was really,
Well, I
really
hope
wonderful. Very
the attendees
interesting.
must have enjoyed the glimpse of what LPU is offering. So yes, these kind of programs at LPU which has been offered to make you people well ascertained with the fact that the current challenging scenario is really there to handle with knowledge. And for that, I'm requesting the Dean of School, Dr. Neeta Raj Sharma, once again to please talk on to the programs that where we are offering these kind of practices at LPU,
Yeah.
so that the attendees could be benefited in near future. So over to you,
Yeah,
Neeta ma'am.
thank
And,
you. Yeah.
uh,
Thank you. Thank you.
if any is
And Dr. Gaurav, thank you very
queries.
much for providing such a informative demonstration to the students and the aspirants. And so far, the rankings of our school is concerned, I'm pleased to share that our lovely Faculty of Technology and Sciences is ranked 51st in an IRF ranking, and we are working on sustainable development goals wherein we are first in India and 40th globally, and we are 10th in life sciences. So far, the programs in our school are concerned. We are offering BTech programs and MTech programs in biotechnology and BTech in biomedical engineering, for which the duration is 4 years, and we have semester system. And in sciences, we have BSc microbiology, biotechnology, forensic sciences, botany, and zoology, for which the duration is of 3 years. And if I talk about the associations we have with the Association of Microbiologists of India and BioClues Organization, KK Nanda Foundation, we have different chapters for these students. We have flexible curriculum for these students, and we are offering different pathways to these students based on their interests. Since time is short, so I would like to take you directly to the projects, that what kind of projects our students do, since
I'm
our
sorry
school
to
is
interrupt. I think
yes.
Slides are needed to be shared. So Rishi sir, if you can please give right to Neeta ma'am for slide sharing. Yeah, now it is fine, ma'am. Yeah, please continue.
Okay.
Thank you.
So there are few projects what our students are doing. This is microbiology student. She worked on a real-time monitoring system for textile effluent treatment, and this work was done in collaboration with TCS by the student, and the technology has been patented. And you can see here the students from zoology, botany, they are involved in various type of product-oriented projects, wherein entrepreneurship also is being done by one of the biomedical engineering students. And you can see the live project done by the biomedical engineering students, and they developed the sticks for the blind. And if I talk about other projects, you will find, yes, this is air purifier using algae, and this device was developed by our students along with the faculty mentor, and ICER Mohali also collaborated in this project. And there are some other projects related to the core genetic engineering based problems, like cloning and functional characterization of heat tolerance responsive genes from potato cultivar. And you can see here one of the students from zoology department, he developed the probiotics for enhancing the fish farming. And further, if I go to the medicinal plant area, one of the students, she worked on endangered medicinal plants. So these all projects are shown because of so that you can get the understanding that what multidisciplinary we are working in School of Bioengineering and Biosciences. And this is the work done by forensic students, wherein they got copyrighted on 2 databases. And again, there is the example of interdisciplinary collaboration with CSC students, and such a nice database was created and copyrighted. And we have different international collaborations with the universities. And If I talk about the placement of our students, the maximum is 11 lakh per annum, and our students are also joining Amazon and other internship, on-job trainings with a very good salary package, that is 45,000 during their internship. And you can see here, we are also working in the entrepreneurship area. Kumar Sahi, our B.Tech biomedical engineering student, participated in lot many competitions and won a very prestigious awards in the competitions by Niti Aayog, and some of few of the awards we have mentioned over here for your reference. And since time is short, so I cannot take more details about the projects, and here in short I will tell that who are the recruiters for our students. So these are different sectors wherein our students are being placed, and quality assurance, quality control, R&D, manufacturing, IT sector. If I talk about IT sector, they are giving very good package, and there are certain recruiters like Capgemini and CTS, this is Cognizant, TCS, Wipro, they are our regular recruiters. And if I talk about the market research, then root analysis is the regular recruiter and very progressive, and our students are getting very good promotions in these companies. If I show you the laboratories, you will find that this is the project laboratory, and it is open till late. After the classes, the students can work. And this is the advanced laboratory in our, this is our central instrumentation facility in the DRD lab, research department lab. And our PhD students, they use high-end equipments in that lab. And this is our School of Bioengineering Biosciences lab, wherein students are working on gel dock system and other ICP-OES just to analyze the heavy metals in wastewater and other liquid suspensions. And you can see here students working on plant tissue culture, and they are using inverted microscope in the animal biotechnology lab. Our microbiology students are using fermenter, and they are in this fermenter, they are working on the various useful products, I mean secreted by the microbes, and these products are various applications. So I again thank you to all of you from Lush Green campus of Lovely Professional University, and I appreciate your patience during this presentation. Thank you very much, and I'm ready here to take the questions. If there is any.
Dr. Minaj, that was really quick and very, very impressive practical work shown by the experts. And it was really, really very informative. Thank you so much. And I think we have covered most of the queries during the webinar only. So I would like to close this webinar by saying that experts, your years of research, your depth of understanding the topic, and your ability to present the topic in such an interesting way produced one of the most wonderful afternoons for all the attendees of this session. On behalf of all the attendees, I would like to thank you for your insightful presentation. Hopefully, the attendees also found this webinar to be valuable enough, and they would be able to utilize the information provided by the experts to take a better decision regarding their career and, of course, their mission. All the best to all of you. Thank you so much.
Thank you, Dr. Rishi, for coordinating with us on this webinar, as ever. Thank you very much. Thank you, Dr. Minhas, for coordinating with the school side, and Gaurav as an expert. Thank you.